Welcome to today's webinar, Continuous Delivery to AWS Lambda. Our presenter today is Andrew Baird. Andrew is a solutions architect at Amazon Web Services in our Atlanta, Georgia office. He has a broad background in software development with experience in areas including distributed processing workflows, e-commerce applications, and public APIs. In his role at AWS, Andrew works alongside AWS customers in the Southeast to help ensure their architectures are designed using AWS best practices. Today with us, we also have George Huang, Product Marketing Manager, Nicholas Waldron, Software Development Manager, Brittany Doncaster, Solutions Architect, Tim Bell, Software Development Engineer, as our webinar moderators. They will be engaging with you and answering your questions throughout the presentation while our presenter presents. Andrew, welcome. The floor is now yours.
Thank you, Ryan. Hello, everyone, and thank you again for joining today's webinar, Continuous Delivery with AWS Lambda. Again, I'm Andrew Baird, a solutions architect out of Atlanta, and I'm excited to talk to you about some important concepts and features we offer when building continuous delivery pipelines to your Lambda functions. Here's how we'll build towards hopefully giving everybody some good foundational knowledge when it comes to applying the concepts of CD, continuous delivery, toward your microservices that use API Gateway and Lambda. First, I'll provide a quick overview of continuous delivery and the benefits it can provide your development teams. Next, I'll describe which pieces of CD we'll cover as part of today's webinar. Then, I'll jump into the important services and features that play roles in that conversation today. After that, everybody's favorite part, I'll do a live demo of what a CD pipeline in Lambda could look like and dive into the implementation details of that demo application. And then after the demo, I'll try to call out some specific things to help make your adoption of these services and features a smooth experience and offer some tips and tricks to take with you. Okay, let's jump in. So again, we're going to start with a brief overview of continuous delivery. Continuous integration is the practice of checking your code in continuously and verifying that each change is built and automated to be tested and verified to follow the standards that you have internally as an organization. It's about taking the code changes that you've made and creating a built artifact that can be introduced into your environment with a lot of confidence that the code which has been checked in is ready to be integrated into the environment. Continuous delivery extends continuous integration to include the testing out to production-like stages and running verification tests against those deployments. Continuous delivery may extend all the way to a production-like environment, but there will be some form of manual intervention between a code check-in and when that code is available for customers to use. Continuous deployment extends all the way of the automated release process to getting code in front of your customers out to your production environment. You'll be able to get changes out faster, get feedback from your customers more quickly, iterate against your code more quickly with automation throughout the entire process. So there are a number of benefits specifically to continuous delivery. You get your code integrated and tested in an automated way, so the long span of test cycles that developers are waiting on are reduced, so that they spend less time waiting to discover if the code they've checked in works as they expect it to. So because of that, their productivity is improved and the bugs inside the code base are identified sooner and they're fixed sooner, which translates to getting your updates and features out to production in a confident way more quickly. So the scope of this webinar, you've got a foundational knowledge now, a little overview of what continuous delivery means. So now we're going to scope down to exactly what we'll be covering as part of the conversation today. So in this webinar, which pertains specifically to Lambda, I'm going to overlook the various source code best practices, build tools, local unit testing frameworks. I'm going to do this because one of the beautiful parts of Lambda is that you're working with real code functions, and likely for those attending, you already have tools that you're using to manage your source code and test it locally. And if there are hundreds of you attending this webinar today, I can bet that there are 100 different practices that you all have around writing code and building it that works for you and your organization. But what does change for everybody when using Lambda is how you introduce those code functions you create into your environment. So I'm covering just that piece of the story today. Some important features and services to take those built artifacts that represent your Lambda functions and deploying them into your lower lifecycle environments whilst performing some automated testing along the way. So which application will we do this exercise in the context of? It will be a continuous delivery pipeline for the application that I demonstrated during last month's Getting Started with Serverless Architectures webinar. It's available on our YouTube channel if you were not able to attend and you'd like to see how we built it. At a basic level, it's a 3-tiered serverless website that allows users to add items to a shopping list. Our role in the exercise will be to act as the back-end service owning team for the application who owns the RESTful API, the back-end logic running inside our Lambda functions, and the DynamoDB database. Our goal will be to make an automated delivery pipeline to take any code changes we make to our Lambda functions and make them immediately available in our pre-production account or pre-production environment without any manual intervention. Now, before I reveal some of the implementation details of how we're going to implement that in the demo, let me give everybody a quick overview of the key features and services that will be used in order to complete that task. So first and foremost is, of course, AWS Code Pipeline. Code Pipeline is a managed service that enables you to build delivery and deployment pipelines that integrate with your source code repository, orchestrate the steps you've defined to build, test, and deploy your software code to make it available in your various software development lifecycle environments. It gives you capabilities to define those things and integrate with a lot of great third-party tools and AWS services natively. It's also very easy to integrate with those tools. It can help you improve your code quality by standardizing the release process. In an automated way, you reduce the chance of customers experiencing errors before you detect them during your automated pipeline processes. You're able to get changes out more quickly. Automating your release workflow with Code Pipeline means that your software is getting to those customers faster, and you can iterate on customer feedback sooner and get newer features to customers quickly as well. Getting started with Code Pipeline is incredibly quick. You can start immediately modeling your release processes. We're currently available in US East 1 and US West 2. There's no servers for you to provision or set up. It's fully managed, and it's available now. You can get started with your first pipeline for free, and then $1 per active pipeline per month. So let's take a look at an example pipeline. Don't worry about the details of this specific pipeline on the screen. If you're interested in it, we had a webinar just yesterday called Getting Started with Continuous Delivery on AWS. That will be available on YouTube in a few days. That will walk you through this example in more detail, but I'm going to use it to help define some code pipeline terminology. First is the pipeline itself. It represents all of the steps and the order of those steps that define how you automate getting changes to your application delivered to your pre-production environments. Next is a stage. A stage is a contained step of your release process that could represent an activity like building your application code or deploying it to a specific lower lifecycle environment. A stage is a collection of one or more of our next term, which are actions. An action is a task that gets performed during your delivery pipeline for a new revision of your application. And finally, if all the actions within a stage complete successfully, your pipeline will proceed to the next stage through what's called a transition. You can have the option of enabling transitions to occur automatically between stages, or you can disable them so that you have manual intervention and decide when your pipeline should take the latest revision and proceed on to the next stage. On the topic of actions, you've got two options for the order with which they happen. You can have actions occur in parallel, or you can define actions that occur sequentially. It's up to you how you configure your pipeline and your stages. Code Pipeline natively integrates with several other AWS services that you can utilize throughout your pipeline processes. And for today's purposes, we're going to mostly focus on Lambda. Also, for everybody's awareness, we've partnered with a lot of popular source, build, test, deployment systems right out of the box to give you integrations that are very seamless when using Code Pipeline. So a lot of the partner applications, platforms, and frameworks you see here on the screen will very quickly integrate with your code pipelines. Another feature which we won't cover in today's webinar, but it's a great feature to be aware of with Code Pipeline that many of you will take forward, is the concept of custom actions. So with custom actions, when you create a worker, perhaps an EC2 instance or perhaps a a server on premises even that has access to the Code Pipeline APIs, or potentially a Lambda function, you can create a custom action that will poll the Code Pipeline service to see if there are any job requests that match that custom action type, and if so, it will receive a slew of metadata about the job request and be able to perform whatever that action requires. Then that worker will notify Code Pipeline of the success or failure of that action. So there's a couple ideas here on the screen of the types of custom actions you might create and introduce into your Code Pipeline. Now what we will cover today is a very specific type of action within Code Pipeline called an invoke action type. With this action type, Code Pipeline will invoke a Lambda function of your choice as part of the pipeline. That code function in Lambda will perform whatever job is necessary with the code that you've uploaded as part of that function. And then once it's completed processing, it will notify Code Pipeline of the success or failure of the job it was just performing. The way the metadata looks, it's provided to that Lambda function as an event from Code Pipelines here on the screen. I know it's probably pretty difficult to read, but for folks that download the slides after the webinar, I would like to take a look and see what the event structure looks like for a Code Pipeline invoke action. I've got an example here, and some of the details it will provide your Lambda function are environment variables or user parameters, which you can set at the action level that are going to provide some user inputted parameters that you can perform logic on within your Lambda function. I'll expand more on that in the demo. Metadata about the input and output artifacts that your action, your Lambda function, will be working with. So an example of which might be the source code that's been uploaded to an S3 bucket. Metadata about where that source code is stored inside of S3 will be provided as an input artifact to your Lambda function. And finally, some artifact credentials as well, so that your Lambda function can utilize credentials which are provided in the event itself in order to retrieve and work with the artifacts that are relevant to that action. So for the pipeline we'll be building today, again, we're going to assume that the application code has already been built. Everybody's got a lot of different options when it comes to building their source code and testing it locally, different languages that are supported, different frameworks in use. So we're going to assume that the built code and the build process is completed, and you have the ability to have that code package land inside of S3. There are many great tools to automate those processes, including integrating with CodeCommit or GitHub and doing that through Code Pipeline as well. But we'll assume for the sake of the demo that your code has been built already and has landed inside an S3 bucket. So after the code has landed inside the S3 bucket where I've dictated that it should trigger the Code Pipeline, we'll first publish a new version of that function using the code that's been uploaded. Then we'll perform some testing of that new function version. And finally, a release step to introduce that new version into the environment and validate it within the environment to determine if we should roll it back or if it should be allowed to remain deployed. And I'll talk more deeply about each of these features and how we do it in a few slides. One thing to take note of, another slide that's very difficult to read, an eye chart, but I wanted to put this in here as well for folks that will download the slides. You should be aware that today in the management console, when creating a pipeline, creating pipelines is done through a wizard, and today the wizard will require you to create a deploy step that either integrates with our code deploy service or our Elastic Beanstalk service. So for a serverless, Lambda-based application like we'll be talking about today, where neither of those two services will be utilized, in order to create a pipeline that doesn't require you to use code deploy or Elastic Beanstalk, you'll create your pipeline through the CLI. So here on this slide, I've got the command that needs to be run to create your pipeline and a JSON document, a JSON object that can be used and stored in a file where you can input the details you'd like to have around your code pipeline and create a pipeline that's Lambda specific to get you started. Okay, now let's jump outside of Code Pipeline and talk about features and services, features related to AWS Lambda that will enable us to create an automated continuous delivery pipeline for the Lambda functions that make up our application. So first is the ability to version your functions with Lambda. Each time you upload new code to Lambda, you have the option of creating a new version. Doing so will give you the ability to do several things. First, you'll be able to see a detailed history of the function packages you've uploaded over time, a deployment history of sorts, because uploading new code to Lambda is all you need for deployment with the service. Second, you have the capability to export any of the function versions code packages. So if you suspect there's an issue that's arisen between two versions, you can directly export the source code that Lambda is using for each of those versions and do any analysis you need to do. Finally, it's a really important concept to take away. Each one of your function versions can be executed in parallel to each other. They execute independently and can be invoked independently. So if you have an older version of your Lambda function still stored inside the service, you can invoke it at any time. This can create a lot of creative opportunities for regression testing, rollbacks, blue-green deployments, etc. Because you may have heard the phrase over time, infrastructure as code, referring to your ability to create artifacts that represent and provision your infrastructure in a programmatic way using services like CloudFormation. Well, with Lambda, you can even flip that around and refer to it as code as infrastructure, because to you as a user of Lambda, your Lambda function code represents all the infrastructure you need in order to run the logic that you've defined as part of that function. Next, I'll highlight a very specific API that the Lambda service provides, update function code. It's with this API that you can programmatically upload new code to your Lambda function and optionally version it. Setting the publish flag to true will create a new version of your function code during this update step. So automating your integration with this API is the crux of creating a CD pipeline for your Lambda code. Next is the feature of Lambda called function aliases. With aliases, you have the ability to invoke a specific version of your Lambda function based on a string you define, like dev or prod or live, so that you don't need to be aware from the client side of Lambda which explicit version should be invoked. You can move these aliases between versions via the console or our API, so that as you deploy new Lambda code via the update function code API and create new versions, once you're convinced that that new function code version is ready for your consumers to integrate with, you can move the alias to that function version so that your clients will seamlessly begin invoking it when integrating. Now to Amazon API Gateway, the client side of our serverless application functions. I'll similarly review some of the features that both enable to have continuous delivery for your Lambda function code behind your API, which is our role in the demo today, as well as for continuous delivery of your API changes themselves should you require that capability. First is the concept of API stages. Stages give you the ability to independently configure some aspects of your API, deploy them independently, and integrate with the API based on which part of the software development lifecycle that API stage sits within. And you'll see this when deploying an API called out as the first level of your API URI path. Here the example invoke URL shows that QA stage on the right there. And one of those independently configurable features is called stage variables. With stage variables in API Gateway, you have the ability to configure parameters whose values will vary from one stage to another that you can reference within a couple different places in API Gateway, like mapping templates and defining your integration backend. This is really important when wanting to build automation for backend Lambda functions that your APIs integrate with. Through the use of stage variables, you have the ability to parameterize the Lambda function being integrated with on the backend of a particular API method. In the example here, I'm showing how you'd reference a variable called Lambda alias with the value of dev, which is then referenced when configuring your integration point for an API method, so that API Gateway won't just invoke the latest version of your Lambda function, but the specific version associated with the Lambda alias dev. Finally, we won't be covering this today in the demo, but if you have the need to build your own continuous delivery pipeline for API Gateway changes as well, you have the ability to use the concepts of infrastructure as code in a couple different ways with this service. First, you can import and export Swagger definitions of your API, and more recently, API Gateway also integrates with our CloudFormation service itself now. Okay, let's move into a live demo. So, for our live demo, here's what a whittled down version of my serverless shopping list continuous delivery pipeline looks like. I focused on a specific aspect of the application, the Lambda function that allows users to add an item to their shopping list. That application function is on the far right and in the middle of that application architecture. And the pipeline on the left will orchestrate making automated updates to that function. And we'll accomplish this in 4 main steps. First, the pipeline is triggered to execute by the source action when a newly built version of my Lambda function code package lands at a specific bucket and specific object key inside of S3. This code package is then referenceable as an input artifact throughout the rest of my pipeline. Then, I move into the dev stage of my application and have 3 functions written, which are application agnostic, to get my function out the door using the update function code API, testing it directly by calling the Lambda invoke API on another Lambda function I've created, which will act as the test suite to invoke the new add item function version to do some light integration testing. And then finally, after those tests have succeeded, I will invoke another action in Code Pipeline to release that successfully tested code function into the environment by flipping the Lambda function alias through the update alias API in Lambda, which will cause the API, which integrates with the function through API gateway, to begin invoking that new version through the use of the alias. Finally, I will invoke directly with API gateway from an API test suite Lambda function in order to be sure that my API does not have any issues when integrating with this new version from the API's perspective. And if it does have issues, I'll roll back my alias to the previous stable version that was used before the pipeline began. And if all goes well, my code will proceed on to the next stage, my QA stage, which is still pre-production. Okay, now let's jump out and I'll walk you through this in real time and give you a couple examples. So I'll start sharing my screen now. Okay, first, let's give everybody a quick glimpse of what the application looks like so we're all on the same page. I have this simple HTML page living inside of S3 that allows users to add items to a shopping list. So if I create a specific shopping list ID, it can be any unique ID, and add an item to it and invoke that function. And these functions are implemented in Java, so because of the cold start time associated with the JVM startup, the first execution will take a little bit of extra time, but the second execution will go much quicker. If I retrieve my shopping list, again, the same cold start time for Java. In a real production scenario where you're working at volume and there are always code functions up and running inside your application, that cold start time might not be something that you've got to withstand. But I'm able to add items just like so. Okay, I have a second version of the same website that represents my QA environment that integrates with a different API stage on the back end. Okay, now I'll give you a glimpse at the code pipeline that manages automated delivery of new code to this environment. So again, we begin with the newly built code landing inside our S3 service at a specific object, bucket, and object key location within S3. And when Code Pipeline detects that that's occurred, by pulling the S3 service, this pipeline will kick off and begin execution. Then, in parallel, I have 3 main application-centric Lambda functions that I'll be processing through that Code Pipeline release process that I walked you through a second ago. First, for the ability to get shopping lists. Second, for the ability to add items to DynamoDB. And third, to remove items from DynamoDB, all through the application. So through Code Pipeline, I've configured this to process each of those 3 in parallel to each other, publishing new versions of those functions, integrating with Lambda functions to act as a test suite for that new function version, and then finally releasing them to the development stage by flipping the Lambda alias, what I've called live, to introduce and allow the API in front of these Lambda functions to integrate with them, performing light integration testings with that API and rolling back if needed. So I'll walk through a little more deeply in a second, but because it takes a few minutes for the pipeline to execute when a change has been checked in and go from beginning to end, I'm first going to walk you through what checking a piece of code in would look like. So, for example, in my dev website here, I've got the functionality that I just described a second ago. But perhaps maybe for some reason your business has come to you and said, we've talked to our users, and the thing that they really want to see with this application is they'd really like all of the shopping list items added to the list to show as all caps. All caps is the new thing, and everybody's talking in all caps and yelling online all the time. So we want our shopping list to be all caps. So you say, great, not my job to question it. Let's make sure everything shows up as all caps inside the shopping list. So I'll go into my code. Don't be too concerned about the code again, because we're not covering the specific build processes today. Or source processes, but I've got a little bit of Java code, and this is the section of my function which allows users to add an item to a DynamoDB table. So I've commented out the place with which the code is adding the item to DynamoDB to a shopping list and inserting it, and replacing it with a couple other lines that convert that item to all uppercase characters, and then adding it to the shopping list. So I'll save my file. I'll build my code locally for the purposes of the demo. So once that chain has been built, great, I will upload it to a specific place inside of S3. And after this upload completes, we'll be able to see that CodePipeline has detected that I've uploaded a new version of this function package, and the CodePipeline process will kick off, and a new revision of my code will be on its way to getting introduced into the dev and QA environments. So if we go back to CodePipeline, it will take a few seconds for the CodePipeline pulling process to detect that the new version has been integrated. So we'll give it a minute to catch. And then once this gets kicked off, I'll dive into the specific details of each action and the Lambda functions that I've implemented to show you a little bit more under the covers of the implementation process and details to publish new versions of your function code, test them, and perform that release step to change your Lambda alias. Okay, great. So we see our CodePipeline is off and running. So while it's off and running, I'm going to go to the edit screen and dive into what each of these stages and actions looks more like in detail. So I have two stages of my application that represent the two front ends, dev and QA, and inside each of these actions, they are all invoking Lambda functions. Every one of the actions that you see here is all tied to a specific function that it's invoking at each step. So first thing we'll do for this particular get shopping list change is we'll be invoking a Lambda function, which I've defined here, publish new Lambda version, which is a function I've written that's, again, application agnostic, and we'll be taking a number of user parameters that I've defined here as my user parameters to give all the metadata required in order for that publish new Lambda version in order to correctly publish the correct environments version of that Lambda function, which function it's operating within. So I'm working within the dev environment. The alias that represents a live code change is called live. The function that this published new Lambda version will deploy is called serverless shopping list, get shopping list. And then I provided to it a test suite, which is another Lambda function called serverless shopping list, get shopping list test dash test, excuse me. And then finally, a function that will represent the API test suite. So these are all the named Lambda functions, so that as my code pipeline Lambda functions themselves are executing, they have these named artifacts, so they know which functions that they should be updating to, flipping the aliases for release, and which ones they should be updating the code for and executing as test suites. So again, I've got these all listed as comma delimited user parameters, which will be provided to each of my Lambda functions for whatever logic is required. The next item worth calling out is our artifacts. So for publishing a new version of my Lambda code, the one thing that will obviously be required as an artifact is the source code revision that was just uploaded. So inside CodePipeline, I've listed that input artifact here, which is the output of the previous source activity. So when that new code landed inside of S3, I have the ability to configure that code artifact being treated as an output resource and as an output artifact, and then referencing it here as an input artifact when publishing a new Lambda function. Finally, within the published new Lambda version, I'll be creating a piece of another metadata object called a test execution object, which I've defined, which will contain which Lambda function version I'm working with currently so that I know where my iterations will go next, as well as which environment I'm working within, so dev or QA. And I'll jump into the code in a minute just to hopefully tie this all together and have it make some sense. Okay. So after we publish development version, so take the code artifact of our newest revision and push it out to the Lambda service to update our function version. The next thing we'll do is invoke that test suite Lambda function, which will perform whatever integration testing we'd like to against that new function version. And the input artifact to this Lambda function will be that test execution object, which will contain the version of the Lambda function that was just deployed. So we know which version of the getShoppingList function that we would like to integration test against. Knowing that, because our API is integrating with Lambda via aliases, that this function, which is now deployed and able to be tested, hasn't been integrated yet with by our end customers because we haven't released the alias to this version yet. And that occurs in our last step within this stage, release to dev, where we provide to it, again, which environment we're working within, what the Lambda alias is that we'd like to update and flip over to our latest version, which Lambda function we're operating within, and finally, which API test suite should be invoked, another Lambda function that we'll invoke to integrate with API Gateway after we've updated the alias to make sure that the changes that have just been made are not backward incompatible with our API, and do some integration testing from the API perspective so that we can determine if we need to roll back or not. And again, each of these invoke actions at each of these three parallel steps is a separate application agnostic Lambda function that I'll dive into. Okay. So we'll cancel any updates here and take a look at where our function has proceeded. So great, it's already passed through the dev stage and has moved on to QA while I've got the ability to walk everybody through the rest of the details. So from a code perspective, to see the things that occur within each of those three steps, the publish new version, test new version, and then release and validate, I'll show a little bit of Java code. Again, because it's Lambda, you've got the ability to work with whichever language of the supported languages you're most comfortable with. But all the code that I'll be showing you is just native parts of utilizing the language and utilizing the AWS SDK. So whether you're using Java or JavaScript or Python, you'll be able to integrate with the AWS SDK to perform the activities that are relevant to my code pipeline, regardless of that language choice. So first bit of code when publishing a new Lambda version is to incorporate all the user parameters that I showed you, that comma-separated list of my environment info, which function I'm about to deploy as part of the pipeline, which test suite needs to be invoked as a Lambda function to integration test that new Lambda function version, and then finally, what is my API test suite to do similar integration testing but in front of the API. So if I zoom in a little bit here to give people a closer look, you can see I'm extracting the user parameters that were passed in by the code pipeline as an event, pulling those out as properties into my code, and then referencing those properties to set parameters so that when I'm updating my function code, I'll be aware within the logic which functions I'm working with, which functions I should invoke, and which environment that I'm running in. The next piece that's worth calling out is the actual update function code request. So the API that I specifically mentioned as part of the presentation deck, you can see being invoked here. So I'm calling update function code request. I'm setting that publish flag to true and providing to it the input bucket name and the input object key where that source code revision artifact was given as an input artifact to code pipeline, and using the function name that was passed in as one of those properties, those user parameters above. So this will update my Lambda function code and create a new version of it. Okay. And then finally, I'll do similar activities and call update function code request to update the latest version of my test suites as well. So all of those things are included inside the same code project. In my case, you're free to decouple as much as you'd like, but anytime somebody changes the code for the actual application-centric Lambda function, I'm also going to update to make sure I'm running the latest version of both test suites as well, calling update function code request in both cases. Now for testing a new Lambda version, so once that version has been pushed out and created, I need to invoke a test suite Lambda function whose job it will be to make sure any integration test that should occur and validate that that new version is going to follow whatever, any tests that I've created for that function will pass. So the first thing that will happen is I'm going to reach out to the S3 service. So the output artifact that was created as part of publishing a new version of my code function and creating that test execution object, which I can show briefly here, which contains the function version that was just published as well as which environment that we're working within. I will pull that down from the S3 service, and Code Pipeline, part of the value it will provide to you is that because you've called it out as an output artifact of the previous function, the previous action, and an input artifact of this current action, it will provide to you a specific object key and the bucket name where that object should be placed if it's an output artifact, and where it has been placed if it's an input artifact from you. So here I'm just getting an object at specifically where the Code Pipeline service has informed me to get that input artifact, and that's going to inform my function code here of which function version I'm testing right now and which environment I'm running within. Okay, so the test suite function, the next API that I'll be calling is the Lambda invoke API. So it's just an invoke that takes in that same test execution request object I just went over, and it's responsible for, in turn, invoking the application-centric function with whatever payloads and event details that it requires to perform some validation and make sure that that new function code will succeed. After it's been successful, once the action is successful or fails, we will notify from our code, we will notify Code Pipeline from our code if this job and those tests passed and were successful or if they failed. So you do this by looking inside of the event that has been passed by Code Pipeline, which will contain metadata about the Code Pipeline job that's in process, and you'll inform through this put job success result API that that action has either succeeded, or if any errors returned by your Lambda function, you'll put job failure results, and your Code Pipeline will either proceed or not proceed depending on which of those two APIs is called. Okay. And then finally, a little bit of code to, once everything has been tested and is successful, I will update the alias that I'm working with for my application-centric function so that my alias live will always apply to the latest successfully tested version of my function code. So I'll integrate with the Lambda API, get alias request to retrieve the current version that that alias is associated with for the sake if I need to roll back. And if I don't need to roll back and proceed, I will integrate with the update alias request and move that alias to the latest version of the new version that's been published as part of this Code Pipeline process. I'll integrate with the API test suite, and if any errors are detected and I get any exceptions back, I will move down to put failure notifications into the Code Pipeline service, as well as update my alias again to the rollback version, the original alias that was just used. So orchestrating all three steps of the process, using those user parameters that you're providing to Code Pipeline so that you know which version of which functions you'll be versioning, deploying those functions to create new versions, invoking test suites through Lambda actions as well, and then based on the success or failure of those actions, proceeding to a release step where you'll integrate with the Lambda APIs to work with its aliases to update the alias and point at that newly tested successfully tested function version so that your API and all your clients who integrate through that Lambda alias will seamlessly begin integrating with that updated version of your function code. Okay. So let's take a look at where we're at now. It looks like my pipeline has succeeded. If I go back to my serverless shopping list and I add milk, we can see that milk has been added in all capital letters now. And similarly, if we go to our QA stage, create a new list, add an item to it, great. So the code change that we made and checked in, sent to S3, has been automated through both environments, including integrating our API to these updated versions of our functions, all seamlessly automated, while I, as a developer, was free to continue giving a webinar while all of these changes took place inside the environment. So great. Last bit that I'll show you is the actual functions themselves, so you get a good sense of the integrations that happen between the three stages. So first and foremost, looking at the front end, if we look at our page source, you can see where the endpoints are being called in some JavaScript. If I zoom in again for everybody, that reference the QA stage of my API. Similarly, if I look at the dev stage of my shopping list website and view its source, I'm integrating with the dev stage of my API, so as expected. Now for API gateways part, if we go to the API gateway console, I have an API again. If you'd like to see how we built this application, take a look at Getting Started with Serverless Architectures webinar from last month. But I have my API definition here, and for adding an item, if we go to its integration definition, we'll see that the Lambda function it's integrating with is directly referencing a stage variable which defines which environment we're in. So for the dev stage, we'll append the stage variable for the environment as part of that Lambda function name, and we're always going to integrate with the alias live. Placing a colon after the Lambda function name, the text beyond that colon represents the alias you'll be integrating with. And so here I've got separate versions of my Lambda functions that correspond to if they're running in our dev environment or our QA environment. So if I look at our stages, and our dev stage, and the stage variables here, I can see that I've got an environment variable called dev, which will be inserted into those Lambda integration requests. And in QA, I similarly have an environment variable called QA as a stage variable in API gateway. And if we look at our Lambda functions that those are integrating with, and whittle down to add item, you can see that I've got distinct and separate Lambda functions here for each environment that I'm working with, a dev function and a QA function. And within each of those, we keep track of the version history and an alias that my code pipeline is helping orchestrate the movement of between old versions and new versions, potentially rolling back if any tests fail. So those are the big pieces that come together and allow me to create this automated code pipeline that my front-end website is integrating with APIs who in turn directly integrate with serverless code functions in Lambda, all while ensuring that the way that those integrations happen is all through a blessed and tested version of my Lambda function code through the use of these aliases, only moving those aliases from one version to the next after I've performed a level of integration testing in an automated way to ensure that the new version won't cause any issues with the function itself or with the API that's integrating with it in front. Okay, great. Okay, let's hop back into the slide deck now. I'll stop sharing my screen. Okay, we'll continue. So some things to be aware of. Next, I want to make sure that as you're adopting these services and features, that there's some things that will help that process go more smoothly for you. So service by service, here's some things that I thought were worth calling out. Remember that, or be aware that different aliases which are assigned to the same version of your Lambda functions share function containers. So your function code should always be alias aware. If you have a single function version that is running both your dev and a QA alias, so in my case I just had a single alias called live, But if you had a dev alias and a QA alias pointed at the same Lambda function version, potentially requests for each of those aliases may run on top of the same function container from an infrastructure perspective. So your code, if you follow that model, should always be alias aware so that you don't have code paths which follow one Lambda alias that accidentally integrate with things for another Lambda alias. Next thing to be aware of with Lambda is that new versions mean new containers, so new function containers. So every time you deploy a new version of your function code, all of your awareness around cold startup times, the amount of scale that you're processing with, all of those things will need to happen again for a new version of your Lambda functions. So pre-warm your Lambda functions through the use of scheduled Lambda functions or CloudWatch events if you need to make sure that before you do an alias cutover to a new version that you've got enough containers up and running to support whatever scale that you need. Next is that in order to publish a new version of Lambda code, there's got to be a change that happens within that source code. So we will do a checksum against the package that you upload, and if we detect that there hasn't been any changes at all to that new that version that you've just uploaded, the operation will still succeed, but we won't create a new version number to go along with it unless something has changed within the code package itself. Next, for API gateway, be aware that changing stage variables do not require an API deployment. Saving a stage variable or calling API to update a stage variable's value takes effect immediately. You don't have to do the explicit API deploy step if all you're doing is changing the value of a stage variable. That can be powerful, but something to be aware of. It's a good way to allow you to make quick configuration changes without deploying a full API, but be aware that if you do make a change and save it, that it will take effect right away. And finally, for Code Pipeline, be aware that the job that's kicked off will hang unless your actions that you have running make the proper callbacks to Code Pipeline for success or failure, and if they don't, it will hang until timeout occurs. Next, the transitions between your stages can either be enabled or disabled. So there's no concept today of manually metering one job at a time to proceed. So if a transition is enabled, any changes made will automatically progress onto the next stage, and if it's disabled, all changes will move up to that transition and be gated until the next time somebody enables the transition again, and then whatever the latest version of the job is that succeeded up to that stage, that will proceed on to the next stage. And the next thing to be aware of, similarly like with creating a code pipeline and having the wizard inside the console today restrict to either code deploy or Elastic Beanstalk. There's a lot of other great features and capabilities that Code Pipeline has, which are inside the CLI and the API. So be sure that you become well-versed in all of those options that you have as well, and not just limit yourself to what's available inside the console. Finally, some tips and tricks to take with you. Number one, for the success and failure callback of your Code Pipeline actions. Implement your failure first. It's a good way to think about test-driven development for your automated pipelines. Implement your action, your invoke action with a Lambda function, and have the first thing that you write be a callback to Code Pipeline that failure has occurred, and only implementing all of the success and all the logic to lead to that success after the fact. Not only will this put you in a good mindset of what your action needs to accomplish in order for failure to not occur, but it will also, as you're testing out your pipeline your first initial times, not having to wait until timeout occurs in order for you to be able to test it again. So think test-driven development and implement your failure callbacks first. Next is think about fan-out testing. Have a single test suite function inside of Lambda or your custom actions that invokes several other test case functions. So this is one way that you can help create really modular test cases that operate as single-purpose Lambda functions, or if you've got a slew of functions that are all pretty quick, but in aggregate they would take a lot of time, it will help speed up your pipeline, as well as potentially allow you to not run into the 5-minute current timeout of Lambda functions. The next thing is a really cool concept that you can take advantage of if you really need to get past that 5-minute timeout for Lambda functions, and that's the use of what's called a continuation token inside of Code Pipeline. And through the use of a continuation token, when you put job success back into the Code Pipeline service as part of a job and provide it with a continuation token, Code Pipeline will again turn around and re-invoke your function with that continuation token so that any statelessness you've got baked into your function, while all of the job state that you can externalize somewhere, like in DynamoDB or S3 about which tests have succeeded or failed, your Lambda function can start up again and proceed with its job wherever it was in the process. Maybe it's output or integrated with an external build provider that's still taking time, that takes longer than 5 minutes, and your Lambda function will pull it until it's complete, and if that Lambda function takes more than 5 minutes, call back to Code Pipeline with a continuation token, and then proceed again once it's re-invoked to see until that job is completed before putting final success, which just means putting job success without having a continuation token anymore to indicate to Code Pipeline that the job is finally completed. Next, for API versioning, for folks that haven't built APIs themselves yet or manage them, don't similarly couple your Lambda function versions to your API versions, called out in the URI path here. Changes to your URI paths are potentially really disruptive to your clients, and we want to encourage you to be able to rapidly iterate against your Lambda code without having to force your clients on the front end of your APIs to have to similarly iterate. Decouple those two processes, version them in a decoupled way as well. Next, if this automated process to get your code out the door is a little disruptive, or you think that's great, but it might be a little too quick for your organization, you can take some baby steps. So you can use the concept of CloudWatch events or scheduled Lambda functions to enable or disable those stage transitions, either nightly or in the morning during business hours while developers are available to fix any bugs that exist. You can time it and so that you solve all the automated benefits of CD, but they happen on some intermittent schedule that you're comfortable with. So take baby steps if that's what you'd like to begin with. Next, for anything that doesn't fall within this application, the serverless components that we discussed here, Lambda and API Gateway, all of the other components of your application, as well as the initial builds of building your pipeline and your application functions. Surround all of that with CloudFormation. It's a great way to allow you to get all of the infrastructure as code benefits and a lot of automation around provisioning from CloudFormation, while still making intra-application updates more frequently through something like Code Pipeline and iterating quickly against your logic and your function code. But large changes being made to your infrastructure, your application architecture, you can accomplish those through CloudFormation. And then finally, one concept that the Lambda service does give you out of the box is the ability to reference the latest version of your Lambda function. So it's something that if you invoke a Lambda function without providing an explicit version or without providing an explicit alias, we will always trigger the latest version of your function code that you've uploaded. For any applications that you're running in production or shared testing environment, I really encourage you to not rely on that. Take advantage, or take control rather, of testing and blessing those function versions and having integrations with those blessed versions occur through explicit versions and aliases like we showed today. So what's next? Expand the scope. Like I said, there's a very small sliver of continuous delivery that we covered today related to Lambda. Expand the scope to include how you're managing your source code repository. Code Pipeline now integrates with Code Commit as a source repository, and also think about other ways that you can introduce more automation into your delivery pipeline through tools like tools for static code analysis or automating your build, integrating with CloudWatch events so that when you put those success and failures inside of Code Pipeline, you're creating a lot of metrics and alerts and alarming. Because you've got the ability to invoke a Lambda function directly from Code Pipeline, the sky is really the limit for the type of logic you'd like to automate inside of Code Pipeline. So take full advantage of all the things you can integrate with. All right. Thank you, everybody. Now I'm going to take a quick minute break before we jump into the live Q&A. We've also posted a number of other poll questions for you to answer as you finish, as we wrap up here today. So please provide us some feedback about the questions you see here, and we'll begin the live Q&A in a minute.
For a great presentation, and to George, Nicholas, Brittany, and Timothy for engaging with our audience throughout the presentation. On your screen, you will see a few poll questions. Please take a minute to reply to these, and we will switch layout shortly, and we will have a few more poll questions in that layout as well. So every time you see a poll, just go ahead and respond. We only have about 3 minutes left. Please continue submitting your questions. Andrew will start addressing some of them, and we apologize in advance if we can't get to all of the questions. Andrew, go ahead.
Okay, I'll pick out a couple of these questions. So we have a question from Robert about, does CodePipeline support multiple AWS accounts? We have a completely separate account for dev and for production. Okay, so yes, the answer to that is yes, you can have cross-account support. We've got good documentation on that. It all depends on the permissions and the repositories that are in play during your code pipeline processing, whether or not the permissions exist to allow those two accounts to have access to the artifacts and to invoke each other's functions, things of that nature. Okay, next question from Eddie is, could you couple this process together with Service Catalog? Good question. So AWS Service Catalog is all about using CloudFormation templates in order to allow end users to have self-service access to provision those CloudFormation templates within their accounts. So I could see a lot of really compelling things you could do to combine this. If you have a DevOps team or a continuous delivery integration team that exists at your organization who'd like to define some of these code pipeline definitions and these the Lambda function code that does all of the integration work, which I showed here today, I think it would be completely feasible to create a CloudFormation template that contains those things which you'd make available to all of your application-centric teams so that they could deploy that pipeline within their own account. So yeah, I think there would be good ways to couple this together with Service Catalog. I think you'd have a pretty compelling story there. It sounds like a good idea to me. Next question from Aaron, will the sample code be available from this demo? It's a great question. There was a lot of code in the middle of that demo that will be difficult to look in YouTube and pause your screen and see what's listed there. So great question. Answer is yes. It's not available right now, but I'm working internally to open source both the code that I used as part of the demo for the actual code pipeline portion of it, as well as the application-centric code for the serverless shopping list. So I plan to have those two things available in the coming weeks, and we'll be able to follow up with all the attendees to let you know when those two things are available. Next question from Anthony is, could you deploy changes to the existing API gateway's production stage using Swagger? So sure, definitely, because you've got the ability to use the invoke action type within Code Pipeline, and that Lambda function's got full access to the AWS SDK, and there is now an import API supported for Swagger definitions and API gateway. I think it's entirely feasible for you to place those Swagger definitions either somewhere as part of the build pipeline process, or export them from a lower lifecycle stage and then export them as an output artifact, which would later be referenced then again as, you know, what you would inject into that import API at a later stage of your pipeline. So yeah, I think there's feasibility to create that kind of automation too.
If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please send us an email at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thanks a lot to everyone here in the audience for taking the time to join us today, and please enjoy the rest of your day.